Good evening, this is Riley Bigelow, and this is Group 1's presentation for Lab 1 for ECN 160. As I previously stated, I'm Riley Bigelow. I'm a junior at BYU-Idaho, and I'm currently studying software engineering.
My name is Ben Doggett. I'm currently a senior, and I am studying software engineering.
My name is Travis Peterson. I am also a senior studying web development.
So the purpose of this lab was to become familiar with the basic logic gates that we'll use throughout the course. We'll also learn how to use LogicSim. 3 would be to verify the operation of the various logic gates that we'll be using. And that was also to understand a real-world problem and to create a digital circuit to solve that problem. And it was to get a little bit more hands-on training about specific tools we'll be using throughout the course.
So first we need to understand these gates. The first gate we have here is an AND gate. When the inputs of the AND gate are both true, that is the only time when the output will be true. An OR gate, any time that an input is true, then the output will be true. Only time it will be false is if both are false. A NOT gate just reverses the input. So if the input is false, the output will be true. A NAND gate is as if you put a NOT gate at the end of an AND gate. So the only time it will be false is when both inputs are true. NOR gate, very similar, but this time the only time it is true is when both inputs are 0 or false. And finally, an XOR gate, this is when one input or the other is true. If both are true or both are false, then the output will be false.
Now that we have that basic understanding of logic gates that Travis illustrated for us, we can now move on to part 2 of our lab, which is our laptop microprocessor. Now we need to understand what our inputs and outputs will be. Inputs will be our power cord, low voltage, and temperature, and our outputs, of course, will be for the alarm and fan of the laptop. Below, we have the exact operation following the truth table, where we can see the cord, the low voltage, the temperature, alarm, and fan, and when those inputs will be false or when those inputs will be true. From this truth table, we can go ahead now and build our Boolean equation. From here, we'll be first focusing on the alarm. When the alarm equals C naught V T naught or C naught V T, we've gone ahead and used our simplification theorem, which is XY or XY naught equals X, and been able to simplify the alarm to C naught V, which from the iLearn format is V C naught. Next, focusing on the fan, we equals C naught V naught T or C V naught T or CVT. Again, we've duplicated the C V naught T term and used once again the simplification theorem, giving us the iLearn format of CT or TV naught.
So from those equations that Ben just described, we're able to implement them in LogicSim using 2 NOT gates, 3 AND gates, and 1 OR gate. For the alarm, it took 1 NOT gate and 1 AND gate to implement that correctly. And for the fan, since it has 2 terms, it took 2 AND gates, 1 NOT gate, and 1 OR gate. So when we ran this through the submission process, we can see that the circuit was able to successfully pass on all conditions and all variations and combinations for cord, low voltage, and temperature. So from this lab, our group was able to learn and understand that simplification of Boolean expressions allows for a simplified circuit and that are easy to implement and easier to understand. Although simplification does not come naturally to many, the practice of it is worth it as it can, again, lead to cost-reduced circuits. Real-life applications that we have learned from this lab is one, that the laws and theorems that we have learned to reduce the Boolean equations can apply to any coding program or coding language where you have to have Boolean expressions, and we can reduce those to make them easier and to implement and understand as well. We also found it to apply into our personal lives through the gospel of Jesus Christ, where we can look to see where we may be having overcomplicating things, and we can look to reduce them to keep them simple and easy to understand. This is our presentation for Lab 1 on ECN 160. We thank you for watching.